In this video, we will look at the different types of earthworks that may be undertaken on a roading project. The road is supported by the existing soil or rock that underlies the road. If it deforms, then the road above also moves, which can result in the road not being usable or, in other words, it fails. Therefore, it is important that the underlying soil or rock can support the road without moving. There are different types of earthworks. Road sections may be at the existing ground level, in which case the earthworks just involves removing the topsoil and shaping the road as shown in the top illustration. The road may need to go through a hill, or otherwise be below the existing ground level, in which case the earthworks need to form a cutting. Alternatively, sections of the road may need to be above the existing ground level, so we need to construct a fill embankment to construct the road on. In other sections, the road may run along the side of a hill, which is called a sideling cut. The hill section may be a balance of cut and fill, as shown here, or it may entirely be in cut. Roads typically involve a mix of these types of earthworks. Let's look at each in a bit more detail. There are several types of cuts. Some cuts involve just skimming the top layer of soil, and this is called grading. Other cuts involve cutting through hills, as shown here. Basically, you start at the top and just excavate down to the designed formation level. The removed material is transported to fill areas or to waste areas on-site or clean fills off-site. The end result is called a cutting. The slopes back to the original ground level are called cut batters. They need to be cut at a slope that will remain stable over time. Weathering can change the chemical composition of the soil, which can weaken it and destabilize the slope. The slope will also become saturated by rain, and the additional weight of the water in the slope soils can also destabilize it. Erosion by rain and wind can also remove material off the slope and may also result in the whole slope becoming unstable. This is particularly a problem with non-cohesive soils, such as sands and gravels, which rely entirely on the interlocking of soil particles for their stability and are easily eroded unless they are protected with topsoiling and grass, sprayed concrete, netting, or another type of covering. Therefore, the batters need to be designed to maintain stability over long periods of time in all weathers. The stable slopes for a batter vary with the materials. Some rocks and residual soils can stand almost vertical, while sands and gravels need relatively shallow slopes and often need additional stabilization, such as sprayed concrete. Another type of cut is a sideling cut. This is where you cut around the side of a hill so one side has a slope above it and the other has a slope below it. The removed material is transported to fill areas or to waste areas on-site of clean fills or clean fills off-site. In this case, one side of the road can be drained by letting the water flow off the low side of the road, although care needs to be taken to ensure the runoff does not erode the slope under the road. If that is a risk, then it is best to put a drain in beside the road and transport the water to a safe disposable area. There needs to be a drain on the other side. Fills are areas where the soil is laid to raise the ground level above the existing ground level. They are also known as embankments. The fill material comes from the cut area or is imported from off-site. Fill is laid in layers of about 200 millimeters thick across the whole fill area and compacted. The compacted material is tested to ensure it is at the required density and strength before the next layer is laid. So, we overbuild the fill, compact as much as we can safely, and then trim the slope to the required shape. Another type of fill is a sideling fill. This is where you construct a fill on the side of a hill. The main risk is that the whole fill structures slide down the hill. Therefore, when we construct fill on a hill, we cut benches into the existing ground and we build the fill into the benches. Additionally, a trench is usually constructed at the foot of the fill, which is also part of the fill structure. This is called a shear key. Benching and shear keys key the fill structure into the existing soil structure and prevent the fill from sliding down the hill. The fill is constructed in layers of about 200 millimeters thick, with each layer being tested before the next layer is laid. The fill is also usually overbuilt and then trimmed to allow compaction of the complete width of the fill. We can also have cuts and fill on the same road cross-section as shown here. This is a cross-section of a sideling cut that has a fill slope next to it. When constructing this structure, the constructors would cut the benches in the existing ground and then relay the excavated materials in layers, with each layer being compacted before the next layer is placed. The sideling cut material is then cut and placed directly on top of the fill and compacted. This results in the fill being one soil structure keyed into the existing soil body. As mentioned for the other fills, the fill is constructed in layers of about 200 millimeters thick, with each layer being tested before the next layer is laid. The fill is also usually overbuilt and then trimmed to allow compaction of the complete width of the fill. Often this earthworks operation just requires an excavator cutting from one side, then turning and dropping the soil on the fill side with a roller compacting the fill as it is placed. The excavator then trims the fill back to the compacted material and the final shape. Earthworks for a road typically consists of cut and fills. That is areas where the soil is excavated, that is a cut area, and areas where soil is placed, that is fill areas. There may be a mix of the different types of earthworks along the length of a road project with cuttings in one area, sidling cuts and fills in another, and fill embankments in another. Managing the cut and fill soil volumes is an important part of designing and planning an earthworks project. Usually the soil that is cut is carted or transported to the fill area where it is laid, compacted, and shaped. This operation is known as cut to fill. The best solution is when the amount of soil you cut exactly equals the amount of soil required for fill. This is called a balanced cut to fill and is the most efficient and cost-effective earthworks project, as you do not have to spend extra time and money disposing of excess materials or importing extra fill. Usually the designer will try different vertical and horizontal alignments to get a balanced cut to fill. However, sometimes this is not possible and you are stuck with excess cut or excess fill. Some earthworks projects may have unsuitable soil or excess soil which cannot be used in the fill areas and so it needs to be put somewhere else. This operation is called cut to waste. The excess or unsuitable material may be carted and disposed of off-site to a clean fill, but this is expensive as you have to pay haulage costs and tip fees. Where possible, a better solution is to have a disposable area on-site which is not supporting the road and where the soil can be laid. Other projects may need more fill material than is available from the cut. In this case, you can import material from off-site, but this is expensive. A less expensive option is to excavate material from on-site, but that can only be done if there is a suitable area that can be excavated. The area where the additional soil is removed is called a borrow area.